Hello and welcome to Applying the 2022 OSSRA Findings to Software Supply Chain Risk Management. Today's webinar is sponsored by Synopsys and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, and slide advancement issues. But if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. First, there are several resources from Synopsys. There's the OSSRA report itself that's a focus of the discussion today. There's a guide to securing your supply chain solution and several other PDF reports. You'll also find a link to Actual Tech Media's Guerrilla Guide Book Club and the ATM Event Center, which is a calendar of events like this one. I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in your handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today, Tim Mackey, who is Principal Security Strategist at Synopsys. Tim joined Synopsys as part of the Black Duck software acquisition, and he's been doing security strategy since then. Tim, welcome to the event. Great to have you here.
Thank you, Scott, and thank you for not reading this entire bio. At some point, we will get shorter versions of these things. But as Scott mentioned, the questions, those are key. One of the big things that I'm going to be doing today is making certain that I don't just read you what's in the report. You can read the report yourself. You can go and see what the actual data is this year. What we're going to try and do is tie everything back to a topic that's really front of mind to everyone, which is this whole concept of a software supply chain. For practical purposes, this whole idea of a software supply chain is something that really hit mainstream last year when President Biden issued an executive order on cybersecurity. It's got the glorious number of 14028. So you may hear me reference EO 14028 a bunch of times throughout the webinar. That's where that's coming from. The other thing that the OSSRA does is we've been doing this for a bunch of years now. So I'm going to be comparing trends that we've seen over the years to what we're seeing this year to give you actionable information that you can kind of be able to take back to your teams, presumably today. So the core agenda, it's important to understand the data source for any report that you've got out there that's coming in. Doesn't matter how reputable it is. If you don't understand the data source, it's quite easy to make some misunderstandings or miscomputations with the underlying data. We're going to talk about open source risks and supply chains. We're going to talk about what the OSSRA data tells us about them, and then draw some conclusions from there. So our data actually comes from M&A transactions. So when a company goes and buys another company or merges with another company, there are a couple of phases that happen from a business perspective. There's obviously some pre-work associated with reviewing whether or not the businesses are compatible and what kind of technologies that they might have and what the people are all about. But there's also a technical due diligence effort that goes along for the ride, effectively to assess how well the software that's being created within the company, and for practical purposes, every company is a software creator at some level, whether they want to admit it, and all of them are software consumers. So getting this technical due diligence right is an important element. We have one part of the Synopsys team that goes and does audits as part of that technical due diligence effort. And there's some serious money on the table if you get these kinds of things wrong. We've been doing this for, coming up on now 20 years. So last year, there was a total of let's call it $1.25 trillion in M&A activity in the tech and telecom space. Last year, that was about a 9% growth in the transactions. But when you look at the overall spending, that's up about 4x from just a couple of years ago. And if you look specifically at the quantity of deals, for practical purposes, the last 6 quarters, so basically all of 2021, going back the last 2 quarters inside of 2020, there were over, almost 1,000 transactions in each of those. And that just goes and shows the level of consolidation that's happening in the marketplace, but also the level of innovation that's being brought into other teams. So that technical due diligence is really important. What we do is we'll take the results of those audits, and there's basically 2 scenarios that we look at, one of which is around intellectual property and development practices, so basically looking at the quality of what's being produced and the development practices teams are using, and then also the security side of the equation. So last year, where there was a 9% increase in the quantity of M&A transactions, we had a 64% increase in the number of code bases that we were asked to audit. And that's pretty substantial because we're talking about some major transactions. Now, one option that customers of the audit service can do is say, well, you know what, we don't care about the security of things. We're just not going to include that. So if you see me talking or you hear me talking about a security stat, this past year, 87% of those 2409 audits that occurred, well, they included a security assessment. The rest didn't. So that's going to become important when we look at things related to operational risk as well as license risk, but not as well as the security side of the equation. So from a distribution of industries, you can see that we run the gamut from software as a service and enterprise software, all through Internet of Things and cybersecurity and big data and aerospace and virtual reality and marketing technology and manufacturing and so forth. We intentionally don't align this to a specific industry that's going to have an associated ID that people would recognize, oh, well, you're in this industry, sub-industry, and so forth. And that's largely because from our perspective, we're looking at the technology, not necessarily what the end result of that acquisition might be. We might not even necessarily know who the acquirer is. We only know who the contracting party is. So we try not to go and draw any unnatural conclusions. These broad strokes, that represents the industries that we're looking at. So that kind of is the backdrop for the data that we have. And importantly, all of this data is conducted as a form of audit, not as a survey. So everything that's in here is objective, not subjective. I, of course, am going to put my color on things, but in terms of the data, it's all objective data. So when people think about a software supply chain, what they're fundamentally thinking about and what they're fundamentally talking about is a set of decisions. And a set of decisions that are made throughout the life cycle of every single piece of software that goes into the actual creation of an application. So at a very high level, that's a combination of code that your teams write. So all that proprietary code that goes and does whatever makes the uniqueness that you are. Then there's code that you rely upon. And for practical purposes, that's mostly open source, but there are vendor third-party libraries and commercial third-party libraries in there. But for practical purposes, you would not be able to deploy this software or execute this software if it wasn't for, say, a Linux operating system, which would be in code that your teams rely upon, OpenSSL for encryption, Kubernetes, Docker, all of these things are all part of that code your teams rely upon. Then a whole series of distributed capabilities, so APIs. And then when you bring all this together, you end up with a set of configurations that are necessary, and that gets you your behavioral stuff. So build all of that out, you end up with what is arguably a software supply chain, but I tend to view it as a little bit more of a software mesh. And that's what we're actually dealing with. Now, it's important to recognize that software supply chain risk is something that you can manage but that you can't control. So the security targets that you have for your own proprietary software development teams, they're not going to be used by third parties. They're not going to be used in an open source world. They're going to have their own security targets. So you have to be careful about what's going on. And the types of risks are also going to be different. So at this point last year, we were all talking about something called a supply chain attack that was effectively going and looking at the development practice of how do I keep my code that I'm dependent upon up to date. And that was effectively a situation where someone could go and bring the latest version of code that was malicious into an organization because the checks and balances weren't there. Then we moved on to what is now being termed protestware, where a developer or development team decides that they're going to make some kind of statement, either that they're upset that their free and open source software isn't making them any money, or that they don't like some political stance or some political situation that we're seeing out there, all as forms of protest. And then they're modifying and effectively polluting their code as a result, all the way through to the whole log4shell, log4j experience that we went through in December and January of this year. Now, one of the interesting things is that the first two scenarios, they're not something that rises to the level of risk that the FTC or the ICO or any other regulatory body is going to really issue statements around. With log4j and log4shell, the FTC basically said, look, if your organization has not solved this problem and has not put in place practices to ensure that you don't fall victim to this, then you are not in compliance with a whole. And those government regulations can be quite substantial in terms of the teeth behind them. So, for example, there was about $170 million in fines that was applied to Equifax as a result of them not adhering correctly. So from a risk management perspective, one of the things that we look at is where is the actual risk being validated within the supply chain. So there's a whole series of risk elements that are focused on the business side of the equation. So business risks on the financial, regulatory risks on the financial, vendor risk management. If there's manufacturing supply chains, there's risk management paradigms all the way through to that. Folks who are in the cyber and IT side of things, well, that's where it starts hitting more of the software, but it's still more about business continuity and data loss prevention than it is about the actual code and how well patched the code is. The software supply chain element is where that actual patch knowledge comes in. And so everything that is on the vendor risk management, manufacturing supply chain, business side of things, a lot of the cyber and IT side, that's designed for slow moving processes, not the fast moving world that we live in. And so as a result, it's a little bit challenged to kind of keep up with the number of CVEs that get published every year. Last year it was 52 a day on average, or the number of library components that might be in an application. In the OSSRA data that we see this year, that's 508. So if you've got 508 potential components that could be compromised with every single application that an IT organization is being charged to operate and manage, from firmware all the way through to line of business applications, that becomes a real challenge. Now, for a lot of organizations, there's this vendor risk management piece that goes and looks at the actual vendor and the core technology up front. And when it looks at that technology, it's performing a point-in-time assessment against a set of regulations. And those compliance regulations are going to dictate whether or not that particular vendor and that solution from that vendor is approved. Once it's in the approved bucket, the real challenge comes in because, well, updates might not necessarily flow through the same risk management. There could be a change in functionality, foam home mechanism, data encryption rules change, you name it. These all become challenges associated with the ability to manage the risk within the entity. And as an example of some of the risks that actually ends up becoming unmanaged procurement or almost a shadow IT type scenario, it's being able to download open source components. The third-party libraries that developers choose to use when creating new applications. If there's in-house development, well, that doesn't go through procurement because it's in-house, but is the security target of that particular application something that is appropriate for use in a different scenario, contracted development, and I mentioned software updates. So if every single piece of software going into an organization isn't going through the same process, then you have different levels of risk and you aren't in a position to actually apply risk management in a meaningful manner. So if I'm building a software supply chain, what I effectively have, if I draw a box around one type of application, I have the functional requirements that are going to be set for that application. I've got all of the languages that are going to be chosen for it, say Java versus Golang versus Rust, the types of test coverage, and all the way through until the operational specifications. That's a nice little box around an application. But that box isn't necessarily reflective of the modern reality. That was true 30 plus years ago, but today it's now more of a chain where the team creating that application, they're going to have a set of dependencies. That's the first order suppliers. Those are the suppliers that they're choosing. The remaining suppliers that are chosen by other teams are part of that software supply chain. And for this year's OSSRA data, as I mentioned, there are 508 dependencies or suppliers within the average commercial application that we audited. So that's a substantial number. So where do these risks come from? What does it all look like? So one of the first things that we look at is the percentage of the code base that is open source. And what we can say is that the innovation boom that we're seeing, that we've been seeing for some time, that's all fueled by open source. So if you, for example, choose the IoT, that's the longest bar on this graph, or you choose telecom and wireless, or retail, or cybersecurity, or big data, those are the next set of long bars on this graph. They all have one attribute in common, and that's that there's a lot of pretty heavy-duty innovation that's going on inside those respective industries. So they need to focus on creating their unique value, not recreating something that someone else has already created. That gives them faster time to market, potentially higher security as well, and gives them the ability to actually deliver that unique and differentiated capabilities up front. Now, that reuse of code, well, it has an associated risk with it, and that's what's known as open source license compliance. So open source software, like every other piece of software out there, has a license agreement. It sets out a series of rights and a series of obligations. And most people think that, well, open source, as long as I can publish the source code on the internet, that I'm compliant. That might not necessarily be true. The list of obligations says what you're compliant with. But not all licenses are actually compatible with each other. And they can create a scenario where you end up with an application that doesn't understand exactly what its license obligations are. So we saw that 53% of the applications that we audited last year contained some form of license conflict. And a perfect example of that is the use of code that says you must go and publish the source code, and another application that makes the publishing of source code optional. So you end up with that duality that needs to be reconciled. The other scenario that we look at is the concept of not licensed. And not licensed can be as simple as the code never has any license associated with it, and the whole paradigm of it's on the internet and I can download it for free so I can use it, right? That's not a license. So that's one class of not licensed. But one of the bigger challenges is that there are classes of licenses that only make sense in specific jurisdictions. So as an example, in the US, we have this concept of a public domain. That concept simply doesn't exist in all countries in the world. So the concept of a public domain license, if you're using software in a different realm, that might not necessarily work out well for you. That's the licensing side of the equation. Then there's the security side of the equation. And if we look at unpatched high severity vulnerabilities, we see that all the industries are represented. Kind of good that cybersecurity has the least or the shortest bar on this particular chart. But again, you see areas where there's a lot of innovation happening, like IoT, having a longer bar, so unpatched vulnerabilities are higher. Then you also see things like automotive and logistics and transportation having a very long bar. And that's for a different reason. those are longer lifespan pieces of software. The software that powers an automotive or vehicle, well, that's developed once round about the time of manufacture, and it might receive a patch or two along the way, but because it's viewed as a closed system, it's not necessarily going to have all of the patches. And as we move into a more connected world, things like a long bar in a long-lived or long lifespan device is something that represents an additional risk that the suppliers of that particular software probably didn't account for completely. So as an example, when was the last time that you updated the firmware in your home router? That's a long lifespan device. There could be lots of patches available. There could be no patches available. But whenever that software was created is probably the last time it received a security audit. So that presents us with a little bit of a scale problem. So I mentioned about the 508 components that were in the average commercial application. Well, the year before it was 528. The year before that, it was 400 and change. It was 300 and something the year before that. So effectively what we're seeing is that the quantity of components, the quantity of suppliers in an average application, well, it's moving up to well over 300. That's been pretty consistent for a while. So if you designed your processes around having only a couple of hundred components per code base, you might be missing out on something. And that's something really becomes a challenge when you look at older components. So 85% of the code bases that we looked at had more components that were at least 4 years old. 88% of them had components that had had no development activity in the last 2 years. And no development activity fundamentally boils down to one of a handful of things. First, it could be the result of the functionality being, quote, done, and there's nothing left to do. It could be a result of the development energy moving away from that project, even if there's still elements of work left to be done, security tests to be run. Or it could be that that particular component isn't actually where the center of gravity was, but you are actually on a fork or a branch of that component. And so you're not seeing those updates. So there's a lot of complexity that comes in when you start trying to think about how you manage an open source supply chain or a software supply chain for that matter. Now, the patching, it's kind of getting a little bit better. I love that cell range number on there. So that should read about 140. So we went from having about 110 to 140 to 138 average vulnerabilities per code base. We're getting better because lower numbers are better, but that still presents a core challenge in that anything in the hundreds for unpatched vulnerabilities, that's still far and away too high. If you look at everything associated with President Biden's executive order, everything associated with patch philosophy, if you're not keeping up to date with these things, then that presents a risk to downstream consumption, a risk to operations. Now, 81% of the code bases that we looked at last year had vulnerabilities in them. Roughly half had high-risk vulnerabilities. So if we start to break down some of the why behind it, a lot of what we actually see is related to foundational decisions. So most people don't go and say, you know what, I want to use jQuery. jQuery is something that I love. I want to use jQuery and make that the best possible platform for me. Now, jQuery comes along for the ride because you've decided to use NPM. And you're going to write an NPM-based application, or you're going to write a React-based application. The decision isn't there, which means that it's not a decision that the average developer is going to be on top of, and that the cybersecurity team may not necessarily be on top of. Similarly with Lodash, similarly with Bootstrap. And then you get into things like the Spring Framework or Jackson Databind. Those are also decisions that are made at some point in the past, and you're leaving with that, that architectural decision today. Now, we always look for the patch situation in being something that's improving. So years ago, we used to talk about Heartbleed. A couple of years ago, we were very happy to see that we saw 0 incidents of Heartbleed within the audited code bases. That long tail phenomena is real. What we don't expect to see is an increase in the number of code bases that have a specific vulnerability. Yet for the first two bars on this screen, that's exactly what we see with those CVEs, both in jQuery and both with greater incidence this year than last year. We look at the middle one and the last one. Actually, if we look at the last three altogether, they're basically at the same rate for 3 years in a row. Those are clear indicators that whatever workflows that are in place simply aren't able to identify that this is a patchable scenario and apply the patch. It's effectively flying under the radar screen. And that's one of the core challenges that we see when we're looking at things related to software supply chains. You have foundational elements, and those foundational elements, well, they're things that you're not necessarily fully aware of and that represent risk to the organization. So almost everybody has some story around the whole Log4j experience last year. So one of the things I decided to do was actually go and try and peel back the onion just a little bit and see what the timeline was. So the first version of Log4j was released all the way back in 1999. The most recent version, 1.2.17, was released in 2012. So it's pretty ubiquitous type component with a long lifespan. And this was Log4j 1. Log4j 2 came into existence in July of 2012. So basically a couple months after Log4j 1 had its most recent version. Some development activity occurred. It was released in 2014, Log4j 2 with version 2.0. And shortly after that, there was an end-of-life statement that was made for Log4j 1 that basically said, look, the last version, which is from May of 2012, it's the last version that there's going to be. Officially, we're end of life. You need to migrate to Log4j 2. When I made this slide, there were currently 6 outstanding CVEs, all with the status of no plan to fix, with an indication of the correct answer. So version 2.14.1 is released in March of 2021. And that is the latest version that was shipped prior to Log4Shell becoming something that was disclosed. So Log4Shell comes out in December 2021. There's now a full flurry of patches over a couple of, well, actually many, many weeks, leading to version 2.17.1, which is the minimum version that, in all seriousness, everyone should be running of Log4j 2. Now, there is a version 2.17.2. And if you look at the release notes for 2.17.2, one of the things that you find is that it's got a lot of patches for things that are related to the migration path from Log4j 1 to Log4j 2. Turns out there were a few issues that were left unresolved. So that migration path, it wasn't as easy as everyone expected. If we look solely at the Java code inside of the OSSRA report, 15% of the code bases contained a vulnerable version of Log4j 2. Now, the next question, oops, normally I have another slide that comes after this. So the next question, we'll just go through and build this back out. So the next question is effectively, well, what does this end up meaning for me? And we did some internal analysis following the OSSRA report. And what we found was that there's actually 3 times as many deployments of Log4j 1.2.17 as there were for Log4j 2. And for anyone who actually went through this whole experience, that was something that came as a big shock, that there was code that has an end-of-life statement stating that the latest version, it comes from 2012, that is effectively powering a lot of Java applications. So when we go take a look and say 80-something+% of the code, code bases include an old component, this is a perfect scenario for that. So, oops, go back. We lost some coloring in this one. So there should be, where we see the white text, that actually should be some red highlighters on there showing components where the incidence of the CVEs, the way that we saw them, increased. We have a couple where we saw a decrease. But the core issue that all of these CVEs have, and that some of them have had for a couple of years, is that they're all falling under the umbrella of data sanitization. So effectively, people are not doing as good a job as you would hope at validating the inputs before providing them into libraries. And part of that is that the libraries themselves do a reasonably good job of interpreting data and just kind of making it work for you. So the real challenge is that if you end up in a prototype pollution scenario, or you end up in a cross-site scripting scenario, you're effectively relying on libraries to do the right things when it comes to processing that type of data. And if you get it wrong, well, the result could be remote code execution or some kind of arbitrary code execution. It's a bad scenario that is actually quite common across these 10 CVEs. Now, one of the mitigations that could be put in place, for example, if there's a choice made to not patch, is to actually use an explicit schema. So effectively telling the libraries what to expect as opposed to relying on it to guess correctly. And then effectively, if you don't know what that data type is, stop. Do not continue to manipulate it, because if you continue to manipulate something that hasn't passed validation, you're in a situation where you might be compounding the problem. And of course, the best solution to all of this is to have an appropriate patch policy, but that's not a substitute for actually having an architecture that is data aware and has schema validation all the way along. So that's all of the badness. What I want to do is kind of focus in on some of the solution side of the equation. So one question that I get consistently is, hey, I'm a DevSecOps team. This is something that I should be able to do all day, every day, and I should be able to take care of this. And the reality is that DevSecOps, for practical purposes, for most organizations, is DevOps with Sec bolted on in some capacity. So the first thing you need to look at from just an efficiency perspective is, what is the measuring stick that you're going to define success using? So in the case of DevOps, it's how quickly you're getting features out, how high the quality of those features are. There's a strong focus on things related to continuous innovation. You want to be able to have incremental testing, not necessarily having something that is going to be comprehensive. So the context of a set of changes, for example, factors strongly into the DevSecOps priority matrix. And because everything's focused on a quality outcome, it's not necessarily going to capture all the security things unless those security things are actually part of what's being passed around. So as an example, if you've shifted left all of the responsibilities, are you then expecting that the security knowledge within those teams that are off on the left-hand side, all those development teams, are sufficient to capture the concept of, say, around and say, I have my InfoSec controls in place. Well, those InfoSec controls are really around data management and data governance. So things like firewalls to protect the edge, or encryption to protect PII. And then some authentication authorization to ensure that, for example, my zero trust network is going to actually have what it needs to have in place when it needs to have it. Those are all things that, when you look from the DevSecOps lens and you look from the InfoSec lens, don't actually capture the types of risks that are present within software supply chains. For that, you need an entirely different language. And so I'm going to kind of end the formal presentation bit here, and we'll go off to the questions. And I can see by a few of them coming in that we've got some good ones. The core objective for any of the software supply chain risk mitigation scenarios is to start with an understanding of what your risk posture is within your current use of open source. So that starts with being able to answer the question of, what is all the software that's powering the business? Because fundamentally, there is no possible way that you can patch something you don't know you're running. So if something actually comes in through a free software download, did you actually have a mechanism in place that allows you to match up the patch and update mechanisms that you currently have with the software that's coming in. Have you actually performed threat models on your development workflows? When all of the various scenarios that were playing out at the beginning of last year around open source risk were playing out, one of the biggest attack vectors was trusting the developer to do the right thing and trusting that the latest update was the thing that you wanted to have. And so you need to go and threat model all of your development workflows to make certain that you don't have a weak link in there where you've got a series of assumptions that can be exploited. You want to make certain that you're scaling all of your mitigation efforts to align with what your development velocity is. Because when you start talking about having 500 components, multiply that by the hundreds to thousands of applications that many businesses have, that's a scale problem. And that needs some form of automation and some form of review to identify where those foundational components are going to come from, because that's part of your supply chain. And the last, and if you get me over a beer, the arguably most important scenario for all of this is to actually figure out which of the open source projects are key to the existence of your business. You might actually be surprised at the types of components that are being used. Log4j, there's no sexiness to Log4j, but it's fundamental. So you need to have some mechanism to identify how log management's working in your organization. But if you identify all of these open source projects and you find some commonalities to them, allow your teams to engage with those projects. They'll learn not just how that particular component functions, but how that development stream functions, and also how to do a lot of collaborative development across multiple time zones and all kinds of fun things. Really advantageous to teams that had more open source philosophy to them during COVID than to teams that had lived within that proverbial four-walled box of we do everything ourselves. And so with that, I'm going to end today's presentation with questions. So Scott, it looks like we've got some good ones in here.
Yeah, we do. And great presentation, and also that timeline on Log4j was really enlightening. So I really appreciate seeing that. That was really helpful to see. And before we get to some of these audience questions, which are really good one of the ones that I wanted to ask you is, is it in an organization's best interest to limit the amount of open source that we use, given some of the, that they use, given some of the issues that you've talked about?
No. So the fundamental problem with open source, and I've been in an open source world for the better part of 15 plus years. I come by the grays honestly. The core challenge isn't one of commercial closed source versus open source somehow being bad. They're different. They're different ways of looking at things. One of the most important is that most commercial software vendors have knowledge of who their customers are so they can push updates out to them. When you've got something that's freely downloadable from the internet, they don't know who downloaded it unless they put some kind of form in front of it that says, who are you and let me know. And I've tried to do that in the past, and guess what? People don't like filling out those forms to identify who they know. So you end up with a lot of Donald Ducks and Daffy Ducks who are downloading things. And that means that the responsibility for patching, the responsibility for engagement, that lies on the consumer side, not on the producer side. And once you get over that hurdle, now you can start to say, so what do I need to do differently? And it really is the open source that's coming into the organization. We can assume that it's just as good as every piece of commercial software that's out there, which means it's probably got some warts on it. But if you don't have the ability to track it and to make certain that you're using, say, the most recent version or a recent version or something that isn't having version spray across your organization, like OpenSSL has close to 8,000 different forks on it. I've asserted for years that I've got dozens of different versions of OpenSSL in my house, what with thermostats and phones and laptops and DVRs and whatever all else. Not to mention the OpenSSL versions that are in my car for all of the various sensors that are there. It's madness. There's no one to fix it.
Right. Gotcha. Great points. So let's go to some of the audience questions here. There's one from Deepak who's asking if a particular version of OS is already in use after vulnerability testing. Doesn't it mean that updating it is more costly?
No. So the cost side of the equation is really one of risk management. So let's take a particular component of open source, and let's just I'm pick anything you want. I'm just going to call it version 2.1 of whatever the thing is. You've gone through the reviews, accepted it. For most organizations, the first order of your review is an intellectual property one. Do I understand the license? Is the license something that I care about? That ticks the procurement boxes. That ticks some of the lawyers' boxes. The next order of business is to do a security review. And for practical purposes, most organizations aren't doing the level of review that you would do on your own code. Partly because it's, quote, somebody else's problem, partly because it's, are you really going to be investing in it? Part of it is who's going to actually act on the results of it. But you can end up in situations where you've vetted everything as every way possible. You've got version 2.1, and something happens, and version 2.1.1 ends up having the beginnings of malicious code coming in. We've seen that before. They could have a developer or the owner of that particular component might decide to take a political stance against, for example, the war in Ukraine. We've seen that. They might decide that they're very upset that Amazon seems to be making a lot of money off of their pet project that they gave away for free, and they're not getting any money out of it. We've seen that before. So even though you've done that initial vetting, there's no guarantee that the subsequent components or subsequent releases are going to be up to the same bar. The nice thing is that if you implement a mechanism that goes and takes a look at the changes, you can actually just look at the changes and say, I did all my homework on version 2.1. Version 2.1.1 looks okay, except that I don't want to use this. And so now you can start to build something out that is your roadmap to when is this component not going to be acceptable anymore. Because the last thing you want to be in a position to do is something bad's happened, like a log4j, and you're left to scramble for a replacement, or to go and have a discussion with a CISO or a CIO about, well, I have to run this vulnerable version because the newer versions actually don't work with our stuff. And now I need to go and invest in, say, instead of the gold edition of some perimeter defense, but the platinum version of some perimeter defense because of this. Or we need additional humans on staff to go and do more exotic pen tests, that type of thing. So cost ends up being in there, just a little bit different.
Right. Interesting. This next one's from Jeffrey, who's wondering, are there any regulatory bodies that govern code, such as compliance and security, or I guess for compliance and security?
So yes and no. Governments the world over have taken stances on software should do things typically related to privacy and behaviors around password management. But in terms of the overall quality or the overall security, we don't have anything yet. And I put yet with a very big asterisk beside it, because with President Biden's executive order, there is a slightly overdue deliverable from the government that sets a series of contract clauses that are going to be necessary to continue to do business with the U.S. government. They are all part of the acquisition rules that the federal government has, and they're going to include things related to if you haven't secured your software this way, if you haven't performed these types of tests, if you haven't, we don't know what the if you haven'ts are just yet. Nominally, this information was due out on the 12th of May, but it's in the coming soon bucket. What we do know is that NIST has produced a bunch of guidelines over the last several years. We do know that the NIST Secure Software Development Framework is going to be part of that set of requirements. We do know that things related to zero trust are going to be part of that. We do know that there is a NIST definition for critical software, so you have to behave accordingly. So these kinds of things do exist. And from my perspective, they form some fairly heavy-duty pieces of the road that we're all going to need to be following, because if we look forward in a couple of years' time, just with the sprawl that the U.S. government has, most companies are going to need to adhere to that set of guidance, whether they want to or not. And I wouldn't make an argument that that's not a bad thing. We don't want another Colonial Pipeline or SolarWinds or anything like that.
Okay. This next one comes from Ned, and Ned was interested in some of the comments that you made about DevOps, and he's wondering if that also applies to Agile DevOps, which focuses on quantity and quickness of integration and delivery, than overall security and quality. Any thoughts on that?
So when it comes to the security side of the equation, there needs to be a set of metrics in place, and they can't just be quality metrics. So I can go and say in an Agile DevOps world, I have a minimum set of changes, and I'm going to have a very sprint-oriented, short-cycle delivery mechanism, and that's going to help contain the sprawl. But if I'm not testing both the impact of those particular set of code changes, whatever they are, say it's only half a dozen lines, and I'm not actually testing them in situ with the rest of the code base, then I run the risk of introducing a type of vulnerability or type of weakness that is the result of the evolutionary sprawl of the application. So you write your piece of code, it goes into my piece of code, we actually end up stomping on each other a little bit, but it's functionally correct, but we've weakened the code. The best example of that I can give is if somebody goes and reintroduces an OpenSSL library that has RC4 enabled on it. We've lost.
Yeah. Okay. Another question. You just mentioned Colonial Pipeline and SolarWinds. We had a question from Sonal, who says, "Excellent presentation, by the way." But
thank you.
Is wondering, if any best practices have emerged based on sort of those supply chain attacks, of the last few years.
So the big thing to recognize is that ransomware, data breaches, PII, data privacy, they're all related to each other, and they're all exploiting a set of weaknesses in the code that's being created. What SolarWinds uncovered was that there was a lot of implicit trust in the humans that were involved, developers trusting other developers, developers going and reviewing each other's work, and that there were easy mistakes the humans could make, say keeping their token around someplace, or accidentally committing it to Git, or accidentally having a token that should never be used in production, put out into production. Those kinds of human errors, they're going to happen, and that we need processes to go and detect when those things happen. Personally, one of the bars that I use is how often I see in the media something about a misconfigured S3 bucket. When I start to see those things going down, it's like, okay, so people are getting the message. We've now moved on to a different class of problem. We'll never hit zero on misconfigured S3 buckets, but fundamentally, we need to be working towards that continuous improvement. That's where the Agile DevOps really shines, is being able to actually have that continuous improvement methodology and paradigm. And that's one that I think we all should be embracing. That would help with some of the things that we see out there. It wouldn't necessarily help with a Colonial Pipeline type scenario, because there you're also dealing with long lifespan code. And well, there's always going to have a set of inherent weaknesses to it.
Gotcha. How do you decide which vulnerabilities are considered high security?
So for me, it's actually the criticality to the application. So let's just say that somebody goes and buys a new shiny tool. They buy the shiny tool from Synopsys just because. And they run the shiny tool on stuff and they find 1,000 issues. That's now going to be a moment of, well, okay, so where do I start? What do I need to do? And for me, the starting point is always the thing that's going to most closely align with the direction that your current set of sprints are running in. So that you can go and start to say, for example, if you're doing a database library migration because you need to go and do some work around performance of queries someplace, that's a perfect time to go and ensure that all of the things related to queries, so SQL injection, are taken care of. So just tick that box, build a burn down on anything that's discovered, and then set a release gate that under no circumstances are we ever going to have a SQL injection weakness reported from any tool anywhere. And then start to build those types of release gates in so that you can see when you regress before you ship.
Gotcha. So there's a really interesting question here from Lee asking, how often should patching be in place for open source? Is there a recommended minimum number, or, sort of time frame to be doing open source patching, like weekly or monthly, or
as it happens? So you're always going to have a scenario of a 0 day. So your goal should actually be continuous notification so that you can go figure out what to do next. So for me, I used to say flippantly, would you prefer to get your security news from the National Vulnerability Database or the Hacker News or the Evening News? They all have different timelines associated with their ability to go and communicate meaningful information and achieve meaningful outcomes. Obviously, you don't want anyone with a C in front of their title coming running down the hall and saying, wait, I just saw this on Good Morning America, and that's you don't want that. You want, yes, boss person, we've actually taken care of this. You're fine. And even with Log4j, we had customers that had already gone through the whole Log4j discovery process, knew exactly which applications were impacted, had put in place their runbook for updates, all before people were getting blog posts out, all before the vulnerability became media worthy. So that's really the objective that you should have, is to be able to have the patch in place, or at least the plan to patch, before someone with a scary title goes barreling down the hall saying, wait a minute, we've got a problem with their hair on fire because they just saw George Stephanopoulos talking about it and he sounded like he knew what he was talking about.
Yeah, CXXs with their hair on fire. That's never a good way to.
Never a good way to start a day.
Sort of a related question, I guess, sort of from a philosophical level. Aren't there always going to be unpatched vulnerabilities? And do you need to patch everyone?
So I make a clear distinction between an unpatched weakness and an unpatched vulnerability. The distinction being that a vulnerability is a weakness that has a proven exploit. So I might choose to have that vulnerability addressed through mitigation or through patching. But because it's actually a disclosed situation, that means that there is an attack pattern somewhere. Now, is that exploitable in my environment? Maybe yes, maybe no. And that's where I look at being able to take CVE information and the architecture of whatever applications we're managing and bring that into tabletop exercises and say, let's just assume for the moment that somebody got past everything and was able to mount this attack. How would we know? Do we have an appropriate mitigation, or are we just relying on the modern equivalent of a firewall and hoping for the best? So that's more the type of scenario that I look at. There will always be weaknesses. There will be changes in architecture that make those weaknesses exploitable. And the best example of that is, if you remember a few years ago, there was a vulnerability called Dirty Cow. It was in the Linux kernel. It impacted how copy on write operations were going to function. And that vulnerability at the time had been known by Linus for about 11 years. They had not found an easy way to reproduce the issue. They'd seen it, but every attempt that they'd made to patch it broke things in other ways. So they just made a note of it and said, okay, well, this is going to be a problem at some point in time. And then it became a problem. And the big change that happened wasn't that the code evolved in a weird way or anything. It just was the number of threads that we could execute on a CPU went from 1 or 2 all the way up to like 32. And suddenly this was a race condition that could actually be exploited.
So it looks like we're running out of time, Tim, but if somebody wants to get started with Synopsys or find out more, what do you recommend?
So obviously you can come to our website and just contact us out. We'll have probably a few people will reach out after the webinar, of course. If anyone has any additional questions that they want to pose to me, I'm on Twitter as @TimInTech. Synopsys is also up on Twitter as @SW_integrity for our software integrity group, which is what I'm part of.
Okay, great. And I just popped up your bio slide again, which has that Twitter handle on it. So if anybody needs that, you can reach Tim there. Well, Tim, thanks so much for being here today. It's been a really, really interesting presentation, and I appreciate all the insights in the Q&A as well.
Thank you, and thank you, everyone.
All right, and with that, before we do wrap up, we have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of the $300 Amazon gift card is Michelle Guo from California. So congratulations to Michelle. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Synopsys for making this event possible. And thanks, as always, for attending and for all of your excellent questions during the Q&A. That concludes today's event. Have a great rest of your day, and we will see you next time.